Hey folks, this is a quick run through of Prism, specifically the synth parts. I'm not going to focus so much on the modulation and effects, though I will mention a few key points there. It's kind of a one-take thing, so please forgive any ums and uhs and misspoken stuff. I have here an init patch that I've kind of put together, and I'll put that in the user library and link it in the video description. So that you can start from here too if you like. We'll listen to the sound real quick. Nothing too exciting there. It's just a starting point. So the first thing we're going to do here is take this exciter knob here and turn it out to the right so that we only hear this exciter section. I'll explain this knob in a little more detail later. But right now, if you're not familiar with Prism, I should say first that the way it works is you have an exciter section here, which generates some very basic sounds for the most part. That goes into your modal bank, which is basically a big array of resonating bandpass filters. And then that goes into some other stuff, these effects. There's a feedback loop, things like that. So where you really get the sound is in this modal bank section, but first we need to understand what's happening in exciter. So you can see here on the left side of exciter, there's an impulse and a noise knobs. The impulse is going to be kind of a click sound, and the noise is going to be like white noise. So let's listen to the impulse real quick. It's kind of quiet. We'll turn it up for this. You can hear it's just a little click. We'll turn this down and listen to noise. You can hear it's just some white noise. We'll mix these two together a bit and just come up with something like that, a noise and a little click. Now that we have some kind of basic sound here, we can talk about this envelope real quick. The way it comes set up on this init patch is as a basic ADSR with a linear attack. If we turn the attack up here, you can see on the display. It's linear. An exponential decay controlled by D2. And sustain and release controlled by S and R. We're ignoring D1 and B here. These are kind of set to off settings. You can certainly play with these if you want, but if you want to use it as a basic ADSR, these are kind of the best settings if you don't mind this exponential decay on it, which is usually fine. If you do want to use D1, which is a linear decay, you need to make sure that B, if you're not using D2, B and S should be set to the same level. So that's a little tip if you want to investigate this envelope further. But for the purposes of demonstrating the synth section, this is fine. There are a few modulation controls for the envelope here. Vel to level makes it velocity sensitive. We can turn that on in here. You're probably also getting a little bit of me hitting my machina pads there. There, that's a little more obvious. Vel to attack turns out that attack, or it's bipolar, so you can shorten the attack with velocity also if you like. We'll leave a little bit of velocity sensitivity on here. Level scale and time scale are key tracking controls. There's a bunch of key tracking controls in the synth. They're pretty helpful for kind of evening out the sound over a wider range. But I'm not going to talk about them too much in this video because they're more for tweaking a sound you've already made and getting it to play better in the ranges that you want to play it in. So now that we know about this envelope, let's go back to the exciter section. We're not going to talk about these four knobs right now. They control the feedback section, and we'll talk about those later when we get to that. I do want to talk about this these filters here. There's a low cut, which is a high pass, of course, and we can hear that. I'll turn this up again. And it has resonance. All right. And then there's a low pass, which is labeled high cut. And it also has resonance. The velocity control here is a velocity sensitivity control for the low pass filter only for high cut. The high cut knob sets the maximum value and the velocity knob controls how low it will go, depending on which note you've played. Right? Or sorry, depending on the velocity of the note. So we can hear that there a bit if you can hear that over my machina pads. There we go. Track is keyboard tracking. This one applies to both high cut and low cut. Again, we're not really going to get into keyboard tracking in this video. Okay, so that's it for the exciter section for now. We'll turn this exciter knob back to the left so that we can hear the modal bank. We'll also need to turn some down here. And we'll start out talking about the modal bank by talking about the time control. As I mentioned, these are a bunch of resonating bandpass filters, and this time control determines how long it takes them to decay. So on the full left here, you'll pretty much just hear the exciter sound. That sounds kind of filtered, right? And that's because of this kind of low pass we have dialed in here. As we turn this up, it'll go through comb filtering sounds and then some more resonant sounds, and then the resonance will really take over. So we'll listen to that. And so you hear it goes quite long. We'll leave kind of a moderate value here. For high amount, what this does is it lowers the decay times. It makes them shorter for the higher partials. And as you turn this further and further to the, when it's all the way right like this, the decay times are all the same. And as you turn this further and further to the left, the decay times for the higher partials get lower and lower. And the highest partials always have the shortest decay times, right? So it'll adjust a bunch of these, but the ones highest are always going to be the shortest, and the ones towards the fundamental are always going to have the longest time. So let's hear what that sounds like. And you can hear it really does not take long to kick in pretty significantly. So we'll leave this at kind of a high-ish value. Track is keyboard tracking for the decay times. Release is a bit like the release control on the global amp envelope on a standard subtractive synth. When it's all the way to the right like this, the decay times are always the same, regardless of whether you tap the pad or hold it down. So I'll tap. Now I'll hold it down. You can hear there's really no difference. As we turn this to the left, more and more of the decay time will be influenced by how long I hold the pad down. So here's a tap. It's very short now, and I'll hold it down. Right. So again, this control can also be quite sensitive, and it doesn't take much to get the effect you're looking for. So these four knobs together let you control the decay times of the partials, and in turn, kind of the decay time of the whole synth. Though that's not entirely true when we start talking about feedback and that kind of thing. Let's talk about cutoff next. And in fact, this whole group of controls here, from cutoff over to AB bow, kind of controls the level of these partials. Yeah, it's all for controlling levels, and you can also group them. We'll talk about that in a minute. But for now, let's just look at the cutoff. And it works pretty much like a low-pass filter. You can pretty much hear that, so we'll hear that. We can also control the slope of this filter, and on the left, it's kind of an exponential shape. Right, and on the far right, you get this kind of very steep low-pass filterish thing. And in the middle, you kind of get a mix. I'll put it somewhere here. Velocity is velocity sensitivity for cutoff, so we can put some of that on. And again, this cutoff knob sets the maximum. And you can see that maximum is right about my hardest hits there. Fund reduces the level of all the partials except for the fundamental, so it's kind of a weird name. But you can see pretty clearly what it does. Only this first partial here is still loud. And that gets quite quiet. You can hear it a little better there. Let's talk about these grouping controls. There's an A group and a B group, and you can set a pattern. Let's first turn this on. What this actually does is it inverts the phase of those partials, and it makes a difference in sound. We'll hear that real quick. So you can hear the sound there changing when I kick these in. I'm going to turn this one on and leave it on because it makes these A and B groups much more clear. We can change the number of partials in each group. You see when we set fractional values, it kind of messes with the levels of the partials that are on the border of the groups. We can set the size from 1 partial all the way up to 20. And we'll just leave this one at, how about 6? And we have the same controls for B. And we'll leave this one at maybe 8. Why not? Shift controls where this, and you see this pattern repeats, by the way. You get 6 from A, then 8 from B, then 6 from A, then 8 from B, and so on. Shift controls where the pattern starts. And again, it will, the fractional values will mess with the levels on the border a bit. We'll have this start right around the 3rd. There we go. AB balance controls the levels of the A and B groups. So if you turn it towards the positive side, you can see the B group there is louder. And if we turn it towards the negative side, the A group is louder. Lastly, over here we have this ring mod control. When it's full to the left, you can't hear the ring modulation at all. You're just getting the output of this A-B balance. When you turn it to the right, you get a ring mod between the sound coming out of the A group and the sound coming out of the B group. It gets quiet. And that can kind of vary in usefulness depending on what exact settings you have with all these other partials. Right, so that's how you control the levels of these partials. The next thing we're going to talk about is how to control their position. And you do that with this ratios section over here. Right, so right now, you can kind of see there's a set distance between each partial, and you control that distance with the bin knob. So let's listen to that. We can turn this up just a bit. You can hear that tends to affect the pitch quite a bit and also leads to some inharmonic sounds. We'll talk about ways to deal with that in just a moment. The multi-control here is, we'll turn this cutoff up all the way real quick. This applies a sine wave pattern to all these bandpass filters in the modal bank. That it applies it to their frequency. So it moves the frequency of these around in just a more complicated way than simply changing the distance between them. So at first, it'll look like it's just making them all farther. But now you see some start to come back as we get into the negative part of that sine wave pattern, right? And so this can, when you turn it up way high, it gets quite random. It also leads to some very inharmonic sounds. They're good for things like percussion or bells. One important thing to understand about this, and I'll spend a minute on this, is just changing the frequency of these partials. You can see that our groups are kind of separated now, right? We don't just have, this 6 in a row from A, and then 8 from B, and then 6 from A, right? They get all kind of jumbled up. And that's because all these controls over here work on the partials in just kind of their index order, right? The first one, the second one, the third one, the fourth one. They don't care what the frequency is. And that's true even of things like cutoff. We'll see if we can see this here. It depends on settings. Yeah, so you can see that these right here are still staying pretty high, even though these ones right next to them are falling quite far. And that's just because these are actually at a lower index, but their frequency has been changed by multi. Right? So I think that can lead to some really unexpected behavior, right? You see a graph like this in a factory preset, and you start tweaking cutoff, and it just seems like random stuff happens. If we turn multi off, we can see it's still just our normal cutoff. It's just that multi has changed those frequencies, and so it can behave in a little bit of a strange way. We're going to turn multi off. No, actually, we'll leave it on for the moment while we explain this. This next section is how you kind of deal with this really inharmonic stuff and clean it up a bit. You've got a high pass and a slope control. This isn't a high pass filter in the sense of frequency. It's a high pass filter in the sense of removing these settings from some of these partials, right? So the further up you turn this, the less these settings are going to affect the low partials. With the slope all the way right like this, it will pretty much completely remove any effect from these controls. And you can see that happening on the graph. And you can hear the sound clean up. We've still got some inharmonic stuff going on in the upper parts, but the base of the sound is harmonic, and so you can get a lot of cool tones this way. This is a really useful thing, and it's worth taking time to understand if you want to get the most out of this synth. Right? And you can hear us going back to our really inharmonic sound there. Let's check out what that looks like with no slope, and to do that we're going to get rid of the multi to make it more clear what's going on. We'll just put a lot of bend on here. Right? And you can kind of see all those controls slowly moving. Partials, sorry. And if you see if we turn bend way up, it never really totally gets rid of it, even on these kind of lowest ones. But if we turn slope up high, then it will. We'll turn this down a bit. One other thing I want to point out here is that you can see it kind of affects all of them all the time. So even these high ones, this does have some effect on depending on your settings of bend, high pass, and slope. For our purposes, we'll just dial in some modest bend here and leave the slope pretty high. And the high pass right about there is fine, I think. Yeah. All right, so now we get to the voice processing section. Right? We've learned how to control the times of our modal bank. We've learned how to control the levels of each partial. We've learned how to move them around in frequencies. And now we're going to talk about our mixer, which is in some ways one of the most complicated things on this synth. I think a lot of people have had the experience where they change second harmonic here and nothing happens. What's wrong with it? And then they change saturation. What's wrong with it, dude? If I change, it doesn't seem to do anything. So what's happening here is that the modal bank goes into this delay section. The delay section goes into the saturator at a set level that you can't change, and then into the feedback path. The saturator is only on the output of the delay. It's never on the output of the modal bank. So right now we don't have any delay mixed into our sound, so we can't hear the saturator. So let's mix in some of the delay. We'll just put it full blast. And now let's turn up the saturator. And you can hear it kicking in there. It's got taking out some of those highs for sure, kind of fattening it up. But it's got a relatively subtle sound. It's not going to totally crush it or anything. We can change the sound of a saturator a bit by changing the second harmonic control. And you see it does start getting pretty distorted there and a bit quieter. when we really have both these dimed. Right, so, oops, sorry about that. We'll just leave this at a modest level. One other thing I want to point out here is that this saturator control has no effect on the feedback path, but this second harmonic control does still work. It still affects the saturator, the delay is still going through the saturator, and so if you change this when you're using feedback, you may indeed notice a change in the sound. This just controls the level of saturation that's going to the output and then through the effects and eventually to you. All right, so let's talk about the delay a bit. We kind of skipped over that. We'll set it at about 50-50 here. This is a really short delay. It goes from kind of comb filter to flam. Let's hear that. Right. And then this phase control controls an all-pass filter from 0 to 180 degrees, but as you know, with an all-pass filter, it affects all the different frequencies differently. So the phase shift is not equal across the whole spectrum. And these controls interact. Right, you can hear the phase sound. The effects of changing the all-pass filter are going to be different depending on the timing of your delay. These also interact pretty heavily with the feedback section, which we'll talk about here in a minute. The last thing to point out here is that you have keyboard tracking for both of these knobs. Right, and so now let's talk about the feedback. We've cleared out the delay here, and we'll just start dialing in a little feedback. And we'll start with positive feedback. Right, and then we'll go to negative feedback. So you can hear with the delay set all the way down like this, the positive side is going to tend to boost bass and the negative side is going to tend to take it out. But that will change depending on your delay settings. Right? And we're not hearing the delay on the output anymore. But that's definitely a different sound than we had before. Right? And if we go back over to the negative side, we can find some spots here where there is some bass boost on that negative side too. And then of course the all-pass filter is also going to change the sound a bit. And let's dial in some second harmonic. And you can hear that kind of thins it out, as we kind of expect from that quieter, more distorted sound that we were hearing earlier. We'll turn these back down so they're not interfering with the rest of our little discussion here. Next thing to talk about is this external knob. This is all the way left. The feedback is always coming through that modal bank, through delay, through saturator path that I talked about. When you turn it to the right, it comes from the effects section instead. One difference between these two is that this feedback is polyphonic, the feedback from the modal bank, and the feedback from the effects is monophonic. So even with no effects in action, as is the case right now, we'll still hear a change. Right? So even if you don't have any effects in use, you can kind of use this just to get some different tones. We'll turn this down for a moment, and we'll just turn on this cabinet effect with whatever settings it happens to have on this patch. And now we'll turn up the feedback. Now we'll turn down the cabinet. Right, so you can hear there's a whole bunch of different sounds you can get from running these effects through the feedback, and then of course it goes into the modal bank again. One other thing I want to point out here before we go on is that this feedback actually comes out of this exciter section. So let's turn this up a bit. We hear our little noise sound. Now let's turn up the feedback. And we can kind of barely hear the effect of that modal bank in there. Right? And so if you're using a non-zero sustain, right now we have a zero sustain. Let's try turning that up. right? And now let's try turning the feedback off. All right, you hear it can really make those frequencies pile up because it's constantly looping back in on itself rather than just being that little click at the start of the sound. So if you have sustain turned up, especially if you have it turned up more than this, be careful with that feedback control because it can really get loud. For our purposes, again, here we're just going to leave the sustain low. The last things to talk about feedback-wise are timer and Fmax. This is kind of an effect, it's kind of a comparator basically on the output from your delay and whatnot over here. And so it turns this kind of complicated signal into a pulse train. Fmax sets the minimum width of the pulse, and then timer is the mix between your normal feedback signal here and your pulse train feedback. So let's play around with this a bit. You can hear the tone changing there. Especially on the negative side, it's making a big difference with these settings. Let's change Fmax. So you hear that can make quite a big difference in the sound, depending on the settings of these controls. As you'd expect, since you're getting a pulse train out of it instead of your normal sound. It's quite a different waveform, even though it's related to your normal feedback. Pretty cool feature, I think. It's fun to play with. And with that, we've explained this whole synth section. So I hope that helps clarify it for you. I'll talk real quick about the modulation and the effects. Here you have a standard LFO, pretty standard controls with some extras like a fade in. You have 2 selectable destinations and a plus minus amount for each of those. You can vary the shape between a saw and triangle there. Over here you have a modulation envelope, which works the same way as the exciter envelope. It's got some preset destinations and one you can pick, again with a plus minus amount. Here we have vel to target, which is a selectable destination for velocity modulation. You can set it positive or negative. Up here we have our macro controls. You can drag them around, or you can just map them to a controller. If you press these buttons, these are controlled by the LFO, and this can be confusing because it's not this LFO. It's this secondary LFO up here, which can be pretty easy to miss, even though it's kind of right next to this stuff. You'll see if I change that rate, it's going to change that. If I change this rate, it has no effect. All right, so just remember the LFO it's talking about. If you're reading these tooltips, I have tooltips turned off right now, but it's talking about this secondary LFO over here. Each of these controls has 3 destinations, and each of these 3 destinations is a separate set of stuff. All right, so the first column is the same for both. The columns are always the same, but in each column, you have a different list of destinations to send things to. So you have actually quite a lot of modulation possibilities in the synth with the modulation envelope, the many places that can go, the velocity, all the key tracking stuff, these macro controls, the secondary LFO and the many destinations here. One other thing I want to talk about real quick is this middle section. I especially want to talk about max partials. Voices and unison here are set in the instrument properties. If you're using Reaktor Player, I don't think you can change these. If you're using the standard Reaktor, you can go into edit mode, but it cannot go over 6 voices. You can just change it to less than 6 if you want, or you can increase the unison in the instruments properties here. We'll get rid of that. Total partials is the maximum number of partials it will play across all voices. If you have a modern machine, I'd suggest just leaving this at 800 unless you're desperate to get rid of some CPU usage. On older machines, you may need to turn this down to save a bit. Max P is the maximum number of partials it will use per voice, and this can be useful to turn down as an effect. Right? You can see as we turn this pretty low, right, it just totally removes all these upper partials. And so you can start playing with bend and multi. This can also, using a lower max P, can also help you get a handle on what these bend and multi controls do if you find yourself unsure. I'll turn that back up to 100. You also have some tuning, keyboard tracking for pitch, unison spread, and so on. Last thing we'll talk about is the effects, and I'm really only going to talk about one effect. Flanger, echo, reverb all are pretty standard. The cabinet emulation here is guitar cab / distortion emulation. I want to focus on this 8-pole filter. This is actually 4 filters. It's a stereo filter with a low pass and a high pass on each channel. So we'll turn the mix of this all the way up. The center control controls your frequency. We aren't hearing it much right now because it's a pretty narrow bandpass. So we can control the width of the bandpass with gap. That's actually notch. And then bandpass, I guess, is going to be to the left. Maybe I had that backwards. Anyway, LR offset here is going to control the stereo width. It just offsets the frequency. Between the stereo channels. The resonance control here is just your standard filter resonance. And then the balance control controls whether you hear the high pass or the low pass. Right? To the right it's high pass, and to the left it's low pass. So that's it for Prism. I hope this video helped you figure out how to use the synthesis section. Sorry about my bobble on this 8-pole filter down here. I actually don't use it much, and so I was just kind of playing around with it right before I did this video. I may have to use it some more. It's actually kind of interesting. There's a lot more to Prism than I've shown in this video. The Prism FX version replaces this exciter section with audio input and envelope follower and so on, so that you can run any audio through here instead of just getting this little click and noise. And that's a lot of fun to play with. I use Prism at least as often that way as I do in this standalone synth mode. Have fun with the synth.